Okay, happy snow day. Welcome to your first video lesson. Now, I am not here tomorrow. I am at a funeral, so I'm not here on Friday. And two kind of poorly timed snow days accompany with that. I don't want us to get 3 days behind of where we need to be. So we have our first video lesson. We're going to finish off quadratics. And then tomorrow you'll come in to class on Friday and you'll work on the questions that I assigned at the end of today. Now, some of you have already emailed me this. I'm going to be sending out a mass email to everyone in the class. So if you are watching this, maybe if you know anyone in the class, give them a quick heads up. Hey, check your email. But so our test obviously won't be on Friday. Our test will be next week, and we'll talk about it. It's not going to be on Monday, obviously, so probably looking at Tuesday for our review test. So you don't have to worry about having to write a test on Friday. So this is where we left off for quadratics. We did this on Tuesday. So we're going to pick up where we left off, and we're switching gears now to factoring. When you are factoring, it says factor completely. You are looking always for a common factor first. So what's the biggest number and or letter that goes evenly into all the terms? So if we look at A, the biggest number and letter that goes into both. So remember, when you're factoring, it's the opposite of distributing, which is multiplying. So really we're dividing. So if you need to, you can write like a little division line underneath each of these. The biggest number that goes into both is 2. And then they both have an x in them. They don't both have an x squared, so you can't take out an x squared. You can take out a 2x, 2x. Don't forget your common factor goes up front. When you divide, you're left with just an x minus 2. And remember, you can always check your answer by doing distributive property. Go back in, you should get the equation back. B. How is B different from A? It has 3 terms. It's got x squared x plane number. So this is what we call a simple trinomial. First and foremost, always look for a common factor. There isn't one other than 1. So how you factor this is you want 2 numbers that multiply to the last number and add to the middle number. Now we're going to go over factoring again in more depth later on in the course. This is just refreshing your memory from grade 10. So hopefully everyone gets it. If you don't happen to do it this way and you want to use the box or window method, depending what your grade 10 teacher called it, you can use that. For now, I'm just going to stick with what's easy and fast for the sake of the video lesson. 2 numbers that multiply 24 and combine to get negative 5. And when you factor a trinomial, it's always going to be like this, x and x. And what you fill in beside that are the 2 numbers that multiply to negative 24 and combine to negative 5. So I'll give you a second to think about it. You can pause the video, see if you want to figure it out for yourself, then hit play when you're ready to see the answer. Hopefully you got x minus 8 and x plus 3. C. This doesn't have a common factor other than 1. It's not a trinomial. It doesn't have 3 terms. This is called difference of squares. How do you know it's difference of squares? Difference meaning minus, 2 terms, and they both have nice square roots. When you recognize it's a difference of squares, 1's plus, 1's minus, and it's whatever the square root of 16 is, which in this case is 4. So x plus 4, x minus 4. The next one, no common factor other than 1. Is there 3 terms? Yes. This is a simple trinomial. X and x, you want 2 numbers that multiply to 16 and combine to negative 8. Again, if you want to pause, see if you can come up with it on your own, that's fine. Hopefully when you try it on your own, you got x minus 4 and x minus 4. And that one's actually called a perfect square trinomial. That's called a perfect square trinomial because both of these are the exact same. So seeing that, what value of k makes each one of these a perfect square trinomial? if we are looking at patterns, if you look back at the example that we just did, our middle term was -8, and we got -4 and -4 as our two factors. And -4 times -4 gave us +16. So if we build off that, half of 6 is 3, and 3 times 3 equals 9. So to make this a perfect square trinomial, k has to be 9. Same idea here. We just did this. If we cut -8 in half, we get -4. And if we do -4 times -4, you end up with 16. K equals 16. So that way, if you had to factor these, so if we had to factor this one, what two numbers add to 6 and multiply to 9? X plus 3, x plus 3. Remember, we can always simplify that too by making it look like that. And over here, what two numbers multiply to -8? Sorry, multiply to 16, add -8, x minus 4, x minus 4, and we could simplify that to this. Now normally I would ask you if you had any questions in the classroom setting. Obviously that's not the case, and if it's going too fast, like I mentioned, you're welcome to adjust the speed of the video at any time, pause, play, at your own leisure, whatever you want. So moving on to graphing. So first of all, this is in vertex form. And remember, this is h and this is k, which really is like your x and y coordinate of your vertex. And the h value is always opposite to how it appears. So in the equation, it looks like h is -4. Our vertex then is opposite -4, +4, and +1. And our axis of symmetry, that's the dashed line that cuts your parabola in half. It is always the x coordinate. So x equals 4. Opening, does it open up or down? You look at your a value. So here's our a value. If that's positive, it opens up. If it's negative, it opens down. That's positive, so it opens up. And our y-intercept, we can get it from the equation. All y-intercepts, what's true about them? The x-coordinate is 0. So we could sub 0 in x, and you could type that into your calculator. What's 0 minus 4? -4. Squared is 16. 16 times 2 is 32. 32 plus 1 is 33. So our y-intercept with coordinates 0, 33. The changing to standard form and the sketch of our graph. So first thing, I'm going to make our little graph first. So x-axis, y-axis. Plot your vertex. Next, our vertex is 4, 1. 4, 1. And remember, depending on what teacher you had, hopefully they showed you the step pattern. Now the step pattern is the easiest way to graph a parabola, and the three numbers you have to have memorized, 1, 3, and 5, and you always multiply by the a value, which our a value in this case is the number in front, which is 2, which equals 2 equals 6 equals 10. How do you use that from your vertex? Go over 1 up 2, over 1 up 2 on both sides, and next one over 1 up 6, over 1 up 6, 1, 2, 3, 4, 5, 6, and exact same on the other side. Now we can't fit the 10 point on there, so that's okay. We have 5 points, that's more than enough to make a nice parabola. So there's our parabola, and we should label our equation in our graph. Y equals 2 x minus 4 squared plus 1. So there's our sketch. To change to standard form, we're going to start with vertex. And we looked at this last day. When you have something squared, really that means there's two of them. So you could write two of them in FOIL. I also showed you a shortcut last day, or your other teacher showed you a shortcut. I'm just going to skip to that shortcut. So you can FOIL, you should end up with the same thing as me. We also know that's a perfect square trinomial. So x squared minus 8x plus 16 plus 1. Now distribute your 2 in. So 2 times everything inside the brackets. So 2x squared minus 16x plus 32 plus 1. And that gives us a final equation in standard form of 2x squared minus 16x plus 33. If you've done your math correctly, you should notice something. Our y-intercept was the exact same as our c value in standard form, which that's one of the things about standard form, it gives you the y-intercept. If those two numbers are not the same, if you were to do this on your own, that would mean that you made a mistake in either changing vertex to standard, or you made a mistake subbing x equals 0 and above. We are going to try it one more time. X-axis, y-axis. Our vertex is h and k. Remember, h value is always opposite to how it appears. So right now it looks like it's -1, but it's actually +1 and 8. Our axis of symmetry, always your x coordinate of your vertex. Opening, you look at your a value. There's my a value. Is that negative or positive? If it's positive, it opens up. If it's negative, so it opens down. My y-intercept, again, you could sub x equals 0. Use your calculator, go through the math step by step with me. 0 minus 1, -1, -1 squared, +1, +1 times -2, -2, -2 plus 8, 6. So 0, 6. And let's do our sketch first. Step pattern, 1, 3, 5, multiplied by your a value, which in this case is -2, which gives us -2, -6, -10. Plot your vertex, step 1, so 1, 8, right there. Now, last time they were positive, which meant go over 1 and up. Because they're negative, instead of going up, we're going to go down. So instead of going over 1 up 2, we're going to go over 1 down 2. And if you look now graphically, my y-intercept is 6. I've already backed up my algebra from the y-intercept portion with my graph. So we did that coordinate. Now over 1 down 6, over 1 down 6, and over 1 down 10. That will put me at the very bottom of my graph. And we have plenty of points. Do your best to hit them all. Arrows on the end, and then label your graph. Y equals -2 x minus 1 squared plus 8. Changing to factored form. So we could go through some algebra. This is the longest to do. You'd have to go vertex to standard, then to factor, so you have to factor it. But let's pretend like we're at home. It was a snow day, back-to-back snow days. We're lazy, so let's do it a different way. And if you want to challenge yourself, I do challenge you. Change vertex to standard like we did last example, and then take that and factor it. But if we look at the graph, so looking at the graph, factored form ever leads you to the zeros. I have the zeros. There's a 0 there. There's a 0 there. That helps you get factored form way easier than all the algebra I just described. So I have 1 0 at x equals 3, and I have another 0 at x equals -1. My a value is -2. For any form of the equation, the a value is the same. We know since we're making factored form, we want to have two sets of brackets, x and x. Now since I have a 0 at x equals 3, when it comes back into the equation, it's going to be minus 3. And that works, right? 3 minus 3 is 0. I have a 0 at 3 on my graph. That backs it up. Same thing over here. I have another 0, x equals negative 1. When I put it back into the equation, I change the signs. So my factored form is negative 2, x plus 1, x minus 3. Now we could do it the lazy way because we ended up graphing it first and we had nice x-intercepts. If we didn't, we'd have to do it the challenging way, which would be, again, taking vertex to standard and then factoring. Our next example, state the equation for a quadratic with the following features. So a vertex of 3, 1 has a y-intercept of 18. So there's a lot going on here. Since I give you the vertex, you should start with vertex 1. Y equals a. Remember the x value, the h value is always opposite. So x minus 3 squared plus 1. There is only one thing that you are missing that you normally have, and that is your a value. Whenever you're looking for a quadratic equation, typically you're going to have to do some work to figure out your a value. I've implicitly given you another point. I've told you the y-intercept is 18. That has coordinates. 0, 18. One of those is x, or 0. One of those is y, the 18. I can take those values and substitute them in my equation and solve for a. So put 18 in for y, put 0 in for x, and go through the math. 0 minus 3, negative 3. Negative 3 squared is 9, so that gives me 9a plus 1. Now, this would be a cardinal sin at this point. 9a plus 1 does not give you 10a. You can't add those two terms together. Those are not like terms. So what you have to do is bring over your 1. It's going to become negative. So 18 minus 1 equals 9a. 17 equals 9a. Divide both sides by 9. We'll leave that as a fraction. So a equals 17 over 9. Our final equation, y equals 17 over 9, x minus 3 squared, and plus 1. We're going to do the exact same thing, but this time we're going to find it from a graph. Step 1. Now you have an option. Because this graph gave you two different nice things. This graph gave you your vertex, which we're going to say has coordinates 2, negative 4. It also gave you your zeros, which x equals 0 and x equals 4. So you have options. You can start with vertex form, or you can start with factored form. Just to change it up, I'm going to start with factored form. But if you want to start with vertex form, you can. So y equals a, x minus your zeros. So my leftmost 0 is 0, so the x minus 0. My rightmost 0 is 4, so that means x minus 4. Again, the only thing you are missing is your a value. We have another coordinate. The other coordinate is our vertex. Sub that in for x and y, and we can get our a value. So negative 4 in for y, and 2 in for x. Go through the math. What's 2 minus 0? 2. 2 minus 4, negative 2. Multiply those two things, so negative 4a. Divide both sides by negative 4. And we get 1 equals a. So my final equation, y equals 1, x minus 0, x minus 4. You don't even have to write the x minus 0 if you don't want to. You could also write 1x, x minus 4, or any other derivative of that. Do you need the 1 out front? No, I'm just putting it there because we calculated the a value as 1. Do you need the brackets around that first x? No, just putting it there so you can see. But any one of those is fine. Now, if you started with vertex form, that's perfectly okay. You should have still got 1 as your a value. And you would have subbed in either the 0 that was the 4 or subbed in the 0 that was the 0. It was up to you. So, as I mentioned, if you're listening to this, that means you got my email. You did the video lesson on Thursday night, and Friday you're going to work on the homework that I'm about to assign, or C work that I'm about to assign. These dates are a little bit off because we've had a couple snow days. So your review quest is not going to be on Monday. Your review quest is going to be on Tuesday. So on Monday we're going to finish off our review unit. Tuesday you're going to have your quest. And then Wednesday your math life is going to get real. Now I did leave a note for you, the supply teacher, to accept your signed forms. So if you have your signed forms with you on Friday and you still want to be eligible for the 3 bonus marks, please give them to the supply teacher and they'll put them in my folder for me. Otherwise, if you've forgotten them, please bring them back as soon as you can next week. So your C work, do not do this Thursday night unless you really want to. This is your work for Friday and basically your work for homework over the weekend. Complete numbers 8 to 15 of the handout that I gave you already that you've been working on. Now, if you haven't finished 1 to 7, that basically means by Monday you should have 1 to 15 completely done. Well, that's it for me. Have a good weekend, and I will see you on Monday.